Okay. Well, hello everyone. I apologize for the poor quality of the stream so far, but maybe I, Julian Polton, and my colleague Maxime here will be able to
Hi.
compensate. Hi. So, we've opened here the IDE of the hackathon The Accountant. And we're going to show you how it works for those who want to check it out but don't really know how to start. At least I hope it'll work. So, the IDE is pretty simple to use. Code goes on the right. You've got 20 languages to choose from. We've chosen Python because we're big Pythoneers. On the left is the game viewer, where you can see the result of your artificial intelligence, and below is the statement. So we're not going to read out the statement right now, but we can tell you more or less how the game works. Yeah. So you're a man called Wolf, who you can see holding a gun in the viewer, right there, shooting people, and that's the point of the game. You're inside this room. There are a bunch of data points containing incriminating data, and you have to make sure that the enemies collect the least possible amount of data whilst using the least possible amount of ammo. And to do this, you move around the room and shoot people. The enemies will not try to kill you unless you arrive very close to them.
Yeah.
So basically, we have to write a code that will read the general situation of where data points are and enemies are, and then make decisions based on those positions on what to do next in order to eliminate them efficiently and numerously. Hopefully all of them. The points are based on how many guys you kill before the end of the game, and if you've killed them all, you get a bonus score, which is the amount of ammo you have left multiplied by the amounts of data points left.
You can find the exact formula in the statement.
Yes.
And if you can scroll down a little, you can see the values for your movements. So you can step forward to a maximum of 500 units. And if you're close to an enemy agent, the value is 2,000
2,000 units. Yes, the entire map is 16,000 units by 9,000 units. In fact, that's probably the first thing I'm going to do in the code is write down these constants. Well, at least width and height, because I'm sure I'm going to need them. Should we follow any...
In uppercase.
Yeah, okay, uppercase. Okay, so width 16,000 and height 9,000. So inside the IDE is a bunch of stuff here, which is what CodinGame provides us with at the start of every challenge, which is just the standard code that will read the data from the game and output a instruction. The default instruction is just move to the center of the screen. So if I start a test case now, I can see Wolf move to the center of the screen, and I got killed, obviously. Okay. So shall we start coding?
Yeah, maybe I can start with a simple algorithm that try to shoot the closest enemy.
Okay.
Okay. So let's read the code provided by CodinGame. So as you can see, we have our coordinates. Then we have the coordinates of the different data points. And finally, we have the coordinates of the enemies. So I will define a new variable to keep the distance and to keep the distance of the closest enemy. So this closest enemy equal let's say noun, because we don't know yet. Then, inside the for loop, I will compute the distance to that enemy, which is an Euclidean distance, so it's enemy x minus my coordinate, so it's x. Squared, and the same for y. Okay, here it's actually the square distance, which is fine. We don't need to compute the square root because finding the greatest square distance is the same as finding the greatest the closest distance. Sorry. So if the new distance is lower than the current one,
or
yeah, I'm not done yet. Of course, it's not working yet. Then we found another distance, a lower distance, and Julian said you need to check that this closest enemy
is
none or slower.
Yep.
Yeah, okay. Yeah.
Yep.
Okay. Now.
So we've got the closest distance.
Yeah, that's all. But I can print it to our debug console.
The stream on my side has gone completely to pot.
Yeah, I hope that you can follow us. So let's try this. Oh no. Yep. Okay, there is only one enemy, so
Closest distance is appears in the game console on the bottom left of the screen.
yeah, you can see that here. However, that's the square distance.
Square distance, yes.
So let's take the square root,
Okay.
or maybe I should.
No, it's fine. To the power of half.
Yeah, that's the same, of course.
Okay. Yeah, it's the same.
Okay, let's try again. And let's pause. Okay, so the enemy is at a distance of 8,000
approximately.
Yeah, that should be fine because that's more or less the height of the screen. But less. Yeah,
a tiny bit less. But you can see that he's getting closer and closer, and by the time that he's very close, it's the end of the game.
Yeah, because remember that if you are in a distance closer than 2,000 units, you die, and that's the case here. So it's greater. Then on the next step, it's lower. So you get killed. Okay, now that we have computed the closest enemy, maybe we can try with 2 enemies.
Well, how about we shoot him first?
Oh, you want to shoot him?
Yeah, because he's pissing us off. He's making us lose the game.
Yeah, but I want to be sure that it's working.
All right.
Good.
Yeah.
Looks good.
Seems pretty.
Okay. Okay. So now we know the distance between us and the closest enemy, but we want to know the ID of that closest enemy.
Yes.
So let's introduce a new variable. Let's call it
closest enemy.
Closest enemy.
Closest enemy ID.
Yeah, ID. Good. None. It's like undefined. And each time we find a closest distance, or the first time, we will change that variable. Closest enemy ID equal to
Enemy ID.
Okay. I will add some more debug.
To make sure we've got it right.
Yeah.
You can put it into. Oh, hello.
Yeah, sorry.
Yeah.
I need to write to the standard
The standard error, yeah.
trim, yeah. So you want me to switch to the debug mode.
So we can see who is
yeah,
who.
You can click on the gear icon here and change to debug mode. Oh, that's better. So you can see over there the ID of the agent. So it's 0 and 1. And in the debug console, yeah, you can see that we found the closest one. So it's always
at the start of the game, 0 is the closest enemy. But
And
because we're
that's
moving towards the center.
Yeah. Okay.
Okay, can we shoot these SOBs
yes,
now?
we can shoot. So, as you can read in the comment, you can either move or shoot someone. So let's shoot it. Shoot, followed by the closest enemy ID.
Yes, please.
Woo.
So that works.
Yeah, looks good.
Maybe we're going to win.
Yeah, let's try more test cases. So there's a button, play all test cases.
Which does exactly that.
Yeah.
Until a test case is lost. Of course, we might not be scoring very highly in these test cases.
No, that strategy is bad. Because if, in the statement, I don't know if you said before, but the closest,
yes, that's
the
true.
closer to the enemy you are,
the closest to an enemy you are, the more damage you deal to that enemy.
Yeah. So you need to get closer to.
You need to get closer, yes. Also, you need to get closer to kill them quickly to get a higher score, but you also need to be able to evade them, lest they touch you and kill you.
Yeah. So the exact formula is
right there. You've missed it.
No, there.
Oh, sorry.
Okay.
When shooting an enemy, the damage dealt is 125,000 divided by x to the power of 1.2. X is the Euclidean distance between Wolf and the enemy. That's pretty straightforward.
Oh, look at that. We fell at one test case.
Yes, we did. So there's Wolf shooting people and he gets killed, yeah. So not only are we going to have to get closer to enemies to kill them quicker, we're also going to need to make sure they don't kill us.
Yeah, so we need to move. What can we do?
Well, I suggest we, save. I'm not sure if you're going to agree with me with this, but I'd like to save each enemy into like an array, a data structure.
Okay.
So we can easily use them afterwards without messing up our code.
Oh yes. So you want to store all the names?
I'd like to store them all.
Okay, no problem. I'm doing the coding, I guess.
I don't mind. I can do this bit if you like.
Okay.
It's not a problem. So, enemies. Let's make an array called enemies. Actually, why don't we make a class called enemy? Unless you think it's a bad idea, of course. I think we have a...
What?
No, that's not working. I'm testing the autocomplete features of the IDE that I don't know very well. So I'm going to call this one enemy.
And class.
Like that?
No, without def.
Without def. Yeah, def is for functions, sorry. So,
And you can
constructor.
put object.
Yeah, but
Bracket.
that's optional. I know for a
Yeah.
fact that that's optional.
Yeah, but then you don't put the brackets. You don't need them.
Really?
Yeah.
So enemies will start with an X, a Y, and some life. We can also give them a distance, but yeah, let's give them a distance.
And you need def.
Screw it. Self. Wait, it's not self, it's init.
Yeah, that's it. And then the first argument is self.
Line. Enter code. Self.y equals y, self.life equals life, and I'm only including the distance because of the brilliant job you did earlier of calculating them. Distance equals distance. That's all we need for now. Let's make some enemies. So, this array will be called enemies, and for each enemy we will create an instance of the enemy class, which I will be calling E for now. Oh, I forgot to give him an ID. That's the first thing I'm going to give him, an ID. There we go. So we know his name and can kill him as we please. So enemy ID, enemy X, enemy Y, enemy life, we want all of that. I'm missing distance, so we have it here. Do we need distance? Should I include distance?
I don't know.
Well, it's there. If we ever need it, we have it. So now we have a list of enemies. We can even take a look at this list of enemies on the standard error output. Will that work?
No.
Yeah, it is, but it's empty.
Yeah, you don't.
Oh, I forgot to add them. Okay, so enemies append my enemy. Or also, we're not going to actually see any yet.
Yes.
It needs a representation.
So you need to define str.
Don't I need to define repra?
No, str is fine. But it's dash dash.
Yeah, underscore or dash, I don't know. Let's just put ID for now. Okay, we need repra.
Or maybe only.
Yeah, well then repra will provide the string when inside, for example, here inside an array, when you're outputting an array. Whereas if you actually do, if you print it, str will be called. But since for us it's the same thing, we can just return str of self.
Okay.
That'll work. Nope. It has to be a string. I forgot to cast it into a string. There we go. So all of our enemies are accounted for. So we have a nice little array to use in order to kill them.
Yeah. There's something very interesting here, is that when you kill an enemy, it's no longer in the list.
Yes, correct, because this code is executed every single step.
Yeah.
Hence the infinite loop. Which is why enemies 0 and 3 are missing, because they have died. We can check that right here. Enemy 0 and enemy 3 are the first to go. Yep. So shall we, what was the objective here? To get closer or to avoid?
To avoid.
Okay. How do we do that?
Yeah. There is a very simple algorithm to avoid an enemy. It is to find the closest enemy and to go in the opposite direction.
Now that is a good idea. We happen to have the closest enemy.
Yeah.
We even have his ID.
And its distance.
And his distance.
Or maybe we should store not the ID of the closest enemy, but the enemy itself.
That is a very good idea. So instead of closest enemy ID, let's store closest enemy.
Yep.
This will break here. That'll.
No, that's closest enemy.
Closest enemy. Yeah. That'll work.
Yeah, and below too.
Where? Oh,
Yeah.
there, yes. Wait, I did exactly the same thing in the standard errors. There we go. Good. Closest enemy ID. So now we have, yes, so we have to go in the opposite direction?
Yeah, but only if we are in danger.
Yes. When do we know that we are in danger? Well, we have to be not too close to the enemy, because if on the next turn he is within 2,000 units, we die. So they
Yes.
can move 500 units per turn.
Yes, but let's introduce new variables, new constants.
Let's introduce new constants.
Yeah.
Okay.
So we need the distance.
We can call it danger zone, danger distance, or danger radius.
Do we want the danger radius, or do we want the radius where we get killed first?
That's the same one. That's what I meant by danger radius.
Okay.
Or call it kill zone if you like.
Yeah, kill zone.
Kill zone will be 2,000.
Yeah, and we also need the speed of the agents.
Which is 500. Enemy speed 500.
Okay. So maybe if the closest enemy is closer than
Then
the kill zone
plus the enemy
enemy
speed.
we are really in danger, and we should
Yes.
go
We
in the
should
opposite
get the hell
direction.
out.
Yeah.
Okay.
Let's do that.
So we have the closest enemy, who is closest enemy. Now let's check if his distance. Closest enemy dot distance. That's what I call it, right?
Yeah, but remember that you've passed the square distance.
Oh dear.
So be
How
careful.
about I just change that into the real distance?
Yeah, you can.
Or should I use math point sqrt
That's the same. As you wish.
for the sake of completeness, readability? So if the actual real distance is smaller
Or equal.
or
Yeah.
equal to the kill zone plus the enemy speed, we have to escape. So how do we
Yeah.
escape?
Otherwise, we just shoot.
Fair enough.
Okay, how can we do that? So we have the coordinates of the closest enemy. So basically we want the vector to that enemy, then we can compute the opposite vector. Oh,
Indeed.
so
Call the vector v.
v v is equal to, let's compute for the difference. It's closest enemy dot x minus x, my position, and same for the other coordinate,
Minus y.
y. Okay, the opposite vector is simply v
So it's the same vector with negative coordinates.
yeah. I'm using two variables just to make it more easy to understand.
And that vector is what we're going to use to compute where we need to go in order to escape that enemy.
Yeah, so we want to go to, let's call it next x, to our current x plus the vector
And the same for y, I suppose.
Okay. I'm not 100% sure about this sign, but let's try.
Yeah, let's test. So this time we're going to use the move command, followed by next X and next Y.
Okay.
Give it a go.
Oh,
Oh, let's watch him escape. Yes. Right, so now he can survive. He's still not very efficient when it comes to killing enemies, but at least we passed the test case.
maybe we can test all the test cases again.
Okay. We scored 110 points on the first one, 220 points on the second, 120 points on the third. This is quite good. 120 on the fourth, 148, 311, etc. Wow.
Oh, that was close.
Yeah, that was pretty close.
That was cornered.
No,
No,
it was
no.
before. Cluster, I think. Could you stop the automatic? Yeah.
What? Oh, that's good. Cluster?
Yep.
No, I wasn't. No, maybe I
It was
didn't.
on that one. Which one did you? Which one are you looking for?
Let's see. Yeah, I don't know. It was very fast and look at that one.
Oh,
It's amazing.
so many enemies. Did he just run away from a guy who wasn't walking towards you?
Yeah, exactly. That's kind of stupid.
So that's a
Yeah,
that's an improvement
look
we
at
can
that.
add.
We can slow down the speed. I guess that the closest enemy is this one. Yes. So we are going in the opposite direction.
But so is he.
Yeah, and we're getting closer to the other enemies.
And
And then-
we run away again. Yeah.
Instead of shooting.
Well, how should we compute the directions that enemies are going to take?
Or maybe we can try to go to go closer to an enemy to shoot him.
Yes, let's do
That's
that.
simpler.
That's probably going to give us more points.
Okay, let's finish the computation of the test cases.
Oh, we're quite good, aren't we? With just that simple code.
Yeah, but it's very safe because we don't move unless it's very necessary to move.
Yes. It's a defensive strategy.
Yeah. Oh my god. And you can change speed.
Yeah, I'll put this normal speed back on. Or maybe twice the speed. That's one crazy validator. I mean test case, sorry. Wow, we've scored 1,800 points.
Maybe we can submit this version.
Okay, submit this version.
Do not hesitate to submit at any moment. This way you have a copy of your code and you know how you rank.
Exactly.
Oh, that's amazing.
Wow, we have 13,370 points across all the validator test cases.
Great.
We must be in the top 10 at least. In
Oh,
fact,
yes,
what's
I'm
our
13.
what's our rank? Oh, we don't know yet. Okay. The submit button is behind our heads. Just saying. Because our heads is in front of the submit button.
Okay.
Check the leaderboard. Does it take a while to compute? Yes. Okay, we're not in the leaderboard yet. A lot of people are playing, so it takes a while.
Look at that score.
Wow, 42. Okay, we are nowhere near the top 10.
What was... Oh my god. We are so far.
Yes, but it's possible. No,
Okay, still no rank. But we should be...
should be somewhere here.
Oh,
More than 300.
that's,
More than 400.
that's not good.
Okay,
No, that's better. Because
oh
they
yes,
didn't complete
they
it.
didn't complete it. So
Yeah.
we should be here. Wait, where'd it go?
Yeah.
Oh, we're 378. Congratulations.
not bad.
Just 377 places more to go.
Okay. So
So let's
now-
get closer to enemies.
Okay.
I'll do this one.
Okay.
So, instead of just shooting closest enemy, why don't we find out exactly how close he is, and if he's not close enough, take a step in his direction.
Do we need to take into consideration the data points?
Well, if
Or maybe not now, maybe for later?
we can put them in an array like we did with the enemies.
Okay.
I'll call this this one data points, and it shall contain data. So I will need a class called data. Both these classes are very similar, so we could have just have them inherit a parent class with just x and y, I suppose. But it keeps things verbose this way. So self dot. Do they have IDs? Yes, they have IDs, and they have x's and they have y's. Whoops, like that. Y ID. So that's my object, my class called data. This is where I will instantiate data, data ID, data x, and data y. And I will append it to my data points.
Even if it's not necessary, I think we should add that extra class. Let's call it pointer or coordinate, I don't know. Because we will need to compute the distance through an entity. And
That's true, and it can be a data and it can be an enemy, so we're not
Yes.
going to duplicate code, are we? No, okay.
yes.
So let's call this class point
Yeah, point.
object. Oops. So this class has what? A constructor with x and y?
Yes. Unless you want to call it entity, and then you can also add the ID.
Okay, entity. So it has an ID, an x and a y. Self.id equals ID, self.x equals x, and self.y equals y. Data inherits from entity. It's the same constructor, except super. I think it's super point init. Is this right?
Should be right. Let's see.
It's been a while since I've done some serious object coding with Python. What, does this work? No.
Take no parameters. No, you should. Maybe you need to.
Oh, isn't it? Is it like entity point?
What?
Is that not it?
I think that will work, but let's try super of data.
What, like this?
Yes.
Nope.
2 arguments. Oh, I don't remember.
Yeah, me neither. We could either look it up,
But yeah,
or figure it out.
but for sure entity will work.
What do you mean, like this?
No, without super.
Oh right, okay.
Like you
Entity.
suggest. Yes.
Like I suggested earlier. Okay.
Yeah. Well, I know it's not very clean.
Well, we'll look up how to do it properly, unless somebody else knows. Init is spelled wrong. We've spelled init wrong somewhere. Or maybe.
Oh, yes.
Well, thank you, hipster mouse.
What? You need to accept.
We do not know how to do this properly. Oh god. Well, thank you for the init. Okay, well that seems to work. It's probably not very. I'm sure super comes into the equation at some point. Wait, enemy must inherit from entity. Apparently not.
Okay, let's now define a new function named distance
Distance. Distance to what?
to another entity.
Distance to entity. Well, I'll just call this one entity. So, let's use the same code you used earlier to calculate the closest enemy. Here it is. Let's return the real distance or the square distance.
We can use a square distance.
Okay.
Because it will be simpler for us to understand what we are doing, but it's not optimized.
Oh, so we're going to use the Euclidean distance. Is that what you're saying?
Yes.
So not the squared distance. Okay. So we've got that. Let's give it a go. Here. We need the enemy. Okay.
Yeah, and we don't want.
We don't need distance and enemy.
Yeah,
anymore.
but we are not an entity.
No,
Shall we
but
define
we
us
can
as
we
an
can
entity?
we can define ourselves as entities. Yeah. Let's call this entity somewhere up here me, because it's me and you. Define it as an entity with a special ID.
0?
0. Well, yeah,
None.
0. We don't care about the ID. X and Y. So we are an entity called me. We're going to remove distance from enemy, since we can just calculate that on the fly. Thank you. We might as well just calculate it here actually. Self.distance equals self.distance 2. We don't have the distance. Okay, let's not do that. Let's use this here, e dot distance, so that we can use distance later on.
Oh, you want to store it? Okay.
Well, we don't have to. It's just we've used it here.
Okay,
Okay,
that
tell
should
you
be
what.
distance to me.
Let's not store the distance. Let's calculate
Okay.
it. E dot distance to me.
But you need to compute it twice.
Okay, well let's not compute it twice. Let's put it in a variable that I will call dist.
Okay.
Thank you. Dist closest enemy dot ID, closest enemy dot distance. So we're gonna compute it a third time.
All right.
I suppose it doesn't matter. Distance to me. Inferior to kill zone plus enemy speed.
Oh.
I seem to have forgotten something.
No. You put an extra parenthesis. Correct. What again?
Me is, but it's an entity.
Show me the definition of distance.
Distance.
Oh,
to
you forgot self.
I forgot self.
And you forgot self.
And I forgot
There
self
and
dot
there.
x and self dot y, and enemy y is now y, and enemy x is
It's
now
a
x.
entity. What? No, that's
Entity. Entity dot x. Thank you for teaching me code. There you go.
Good.
Okay, so now we have a list of entities that are either data points or enemies, or in fact me, and we can calculate their distance on the fly whenever we need them. So we don't have to save the distance here, which is good. So we have a list of data points, we have a list of enemies, we want to get closer to the enemies in order to shoot them more efficient. Yes?
Yeah.
Why did you want to take into account the data points?
But maybe we don't need to do that now.
Okay.
But the idea was to don't move if the enemy is very close to a data point. We need to kill him first.
That is a very good point. Why don't we first move towards the closest enemy until we're close enough to kill him, and see if that gives us a higher score than 13,240.
Yeah, let's try that.
Okay, let's try that first. So, if the closest enemy is not too close, we will save the distance instead of putting it into this if. I'm going to call this one dist as well. Hello. Dist. That's twice I've used the variable dist. Else, elif actually, dist bigger than kill zone plus enemy speed. Well, if I just leave that condition, I think that our guy is just gonna chase and never shoot.
But why? That's just the opposite. That's an else.
That's yeah. Well, I know. I'm going to change the condition because otherwise he just chase. Well, actually, I could probably. Yeah, he will never shoot if we only have two conditions: one move away and one move closer. So we need to shoot, and we have a microphone. Hello, Mr. Microphone. Could you come here, please? Thank you. Thank you.
Do we need to configure anything?
Can anybody hear us? Hello?
Is it better?
Our technical engineer is speaking to us. Can you hear us? Are you checking? Good. I suppose the stream has to catch up with 30 seconds in the future. We know first if the world ends in 30 seconds.
Not really.
No, not really. Okay, it's working. Goody. So it has to be bigger than that, but even more so. What's a good distance to kill? Well, at this point I would take a look at the formula and calculate the amount of life points that we would take off.
Okay.
But instead of doing that, why don't we just sort of put an arbitrary value for now?
Or maybe we can double the value.
Or we can double the value. That's perfectly arbitrary. I think someone's asked us a question on the stream. Why did you need a mic when you had one working already? Yes, it's a better one.
Yeah. Unless it's not.
unless it's not. If it's not a better one, now's a good time to say so. Also, we like stealing stuff. Invalid syntax. Yes, I can.
What have you done?
Too many parentheses.
Yeah, again.
Also, I think I've forgotten to actually do the thing, which is to move towards the enemy. Forgot about that. Move. Enemy. Wait, what's his name? Closest enemy. Oh, just copy that. Is there something up? Something wrong with my code?
No, but you've doubled the enemy speed, and I don't know if. Okay.
Happy?
Yep.
Why are we testing on with extreme conditions? Why don't we give it a go with the easier test cases just to see if our code is working first? Yes! Bam! 2 shots.
Oh, maybe we can comment out the code to compare without.
With and without, okay.
Or put and false.
Yeah, I'll just comment out the code. Oh, that worked, yes. Okay, so without, we have 110 points, and with 122 points.
That's 12 points.
That's 12 points for this submission.
Okay.
Shall we submit and see how much we get, or shall we try and improve it even more? Try and one-shot him, maybe.
Yeah, but we can submit.
Okay. Yes, it's good to go incrementally, little by little.
Ooh.
Wow, 90, that's like 4,000 points more. Or something, no, more than that. 6,000 points more. We can check with the history button. Yep, well, 6,300. Well, actually, let's not calculate the exact.
But that's better.
Yes.
Okay.
So this is our escape condition. This is our get close condition. And this is our kill condition.
Yeah. Okay, so you wanted to do one shot.
Yes, let's do a one shot.
That's
So
very ambitious.
kill zone enemy speed doesn't work. Maybe we won't be able to do a one shot, but let's see what happens if we just multiply this by 1.1. I don't know how that I just hope the FPS is. Oh no, okay, that doesn't work. 1.4 maybe. Respect.
That's better. But I was wondering, maybe that would make sense to add the speed. Your speed.
Oh yes, my speed. Now that's a very good point. What is my speed? Let's look at the statement. Wolf, that's me. 2,000. No, that's not it. 1,000 units. We move 1,000 units.
Yeah.
Okay, well let's try that. Is this where you wanted to put it?
Yes.
Okay. Well, we need a constant. Shall we call it my speed?
Yes.
1,000 units per turn. My speed. He's going to kill us, isn't he? Oh no. Perfect.
Good. But maybe it would be even better to consider the next position
Yes.
of the opponent.
Because all we have here is the current position, and they move before we do.
Yeah, and if he's moving towards us, it would be very bad because we are going very, very close.
Yes.
Are we sure that we are still passing everything?
Probably not.
Look at that.
Wow. He's a hothead, that one. Scared of nothing. Oh dear. Well, that was close.
Still?
It's
All great.
not a
It's
bad
all
code.
great.
We're pretty good at this.
Whoa.
Oh. Okay, well, let's take a look at what happened here then. So, what's happening? We're going towards the closest enemy, and then we're too close, so we run away. Which has put us in a tight spot because we can't run away anymore. We run away into the arms of another enemy.
Yeah. So that would be very, very useful to know the next position of all the enemies.
Indeed.
Then we can avoid to do that.
Yes. So in order to avoid this sort of situation, we need to know what the algorithm behind these enemies is, and it happens to be explained inside the statement somewhere that they will always go towards the nearest data point. And it so happens that we have all of the data points in this array here. So, for each enemy, I suggest we calculate where he will be next turn.
Yeah.
Okay, let's do that. Do you want to do this one? I don't know, I think it's kind of fun.
You want me to do that?
No, I don't mind. It's just, to me, to you.
Okay. So we need to store for each enemy what is the closest data point.
Yes. With our closer to method.
Okay.
I just like to take a minute to read the chat and notice that a lot of people are having problems with our video freezing from time to time, and we apologize, and maybe we'll figure out how to make it better soon. In the meantime, please continue.
Okay.
Maybe something we can do on OBS.
Maybe if we reduce the quality, but if we do that,
Do
we
you want
might
to
not
try?
be able to see the code anymore.
Yeah, so continue.
How about we try reducing the FPS real quick?
Okay.
In the settings button. Video. FPS. We don't need 30 FPS, just, I don't know, 15 FPS. Yeah, that's good. We need to reboot the stream to it to work.
Okay.
Do you think that?
Is there something else we can do? That's quite big.
Diminuer la résolution.
There was something you could do as well. Let me check.
It's very big.
Well, yeah, how about 16900?
That one.
No, a bit bigger. Yeah, that one. That should be alright. Okay. Okay, and we need to restart the stream to see if it'll work better.
Can you change the keyframe on the advanced?
The keyframe? Okay, go back in the
2 seconds
video.
instead of 8.
It's not in video, it's in encoding. Okay, it's not an encoding.
No.
Keyframe. Hello. Yeah. Réglage sur le profil. Okay, we should do that. Where's the button? We're changing the video options to make things better. I think it's that one, main. I can't remember what else there was. Apply. Go back. Two seconds. Okay, so go back into options. 2 seconds. Here we are. 2 seconds. Apply. And what was the other thing? What was the other thing? There were 3 things.
Sorry.
Video, maybe? No? Oh, okay. I thought there was another thing. Okay. Okay. Well, let's try that. So press OK, and restart the stream. See you in a second. No, that's not restart the stream button.
That's what?
That's open solitaire. We're back, and our IDE has shrunk.
What?
Click on Edit Scene. Can you edit the scene? Click on the scene. Yeah, you can. Whoa.
What? Yeah.
Intel
Great.
HD. Click on Stream. Double click, I mean. Okay, it's obviously the diminuer la résolution button. Oh, it worked. Okay, cool. Wait, it's a bit too big. Drag and drop the red thing.
I'm trying to.
It's not so bad. Oh, because we've changed. No, we haven't.
Okay.
Okay, that's good enough. Hello.
Hello back. Is it better?
Well, they don't know yet.
Oh,
Remember,
30 seconds.
We're 30 seconds in the future. But apparently FPS is now at 15.
Yeah.
So we're all choppy.
I still lag from time to time.
What?
Okay.
I still lag from time to time, but it's my PC as well. Doesn't help.
Yeah, well, maybe the infrastructure here just doesn't work with Twitch very well. Hello?
It's okay.
Okay.
Where were we? Oh yes, we are trying to figure out for each enemy what his future position will be, so that we don't get, so that we don't get stuck, basically. Because now our code assumes that enemies don't move, but they do.
Okay.
86 people on the stream.
What?
86 people.
Wow. Okay.
So
So that's pretty good. Hello, everybody. I can't see the chat anymore. If you don't mind, I'm just going to grab your cursor, and there you go. You can have it back.
Okay. So I'm iterating over all the data points, and what I will do at the end is saving the entity that is the closest, the data point that
The
is
data point,
closest
which
to
is
me,
the closest. Okay.
to that enemy. Okay. So that's basically the same algorithm than before. So we needed two variables. We needed two variables to store the distance, and so that's the closest distance, fine, and another one that will be the closest data. No. So if the distance between the enemy and the data is lower than the closest distance, yeah, we do not need to follow that. If the closest distance is not, no, is none,
Is none, yeah.
or
Or it's inferior.
it's
Yeah.
closer, yeah.
the sound was better before, I think.
The
The
sound
sound.
was better before.
Oh, I don't know which mic we are using right now.
We can take a look at the mic, but we haven't changed any options regarding sound. It is lower. See, I don't know why. Global source, nope.
Maybe if I...
It's that one. Samsung UB1 is this one.
Yeah, but maybe this one is no better than this one.
But
Yeah, it's supposed to be better.
It's a good microphone.
Okay. Maybe we should
put it
talk.
closer to you.
Okay.
Hello.
Where's my mouse? Okay, so then the closest disk is now equal
Wait,
to...
I'm stealing your cursor again to put the chat back on.
Yeah, you wanted the chat. Okay. That's bad. Let's introduce another variable.
Yeah, so we don't have to
Dist.
calculate it twice.
Yeah, dist. And then
Save the closest.
we
data.
update the variable closest data. So now data. Okay. That's good.
So that finds the closest data point.
Okay.
When do we actually call this function?
Good question. I'm thinking, or maybe we can just say it's private function, and here we can put all the data points.
And compute it upon instantiation.
Points, but not pointers. Okay, and let's do that this way.
You don't need to use self.
Yeah, I need to.
Data points.
Okay. But I don't know if maybe we should return the value close data instead. Would be better.
I might be able to boost the microphone if people are having problems.
Oh, you want to try?
Yeah, click here on the not the open solitaire button, but yeah, that one. You see there? That's gonna, yeah, like that. That might work better. Hello? Can you people hear us better?
I'm not sure it's.
Yeah,
really
it's not.
better.
It's not that better. It's not going very high.
It looks like that's since we've switched the mic.
But no. But even before, I don't know.
Maybe we can try
It
that.
didn't change anything.
Maybe not.
It does. It is going a teensy bit higher.
Yeah, we are back with the old microphone.
Yes. Hello.
Okay, so I was computing the closest data point. It's good. Closest data. What are you doing? Okay.
It's good. Okay, so the sound is all right. Probably not perfect, but good enough. So when we instantiate the enemies, we need to give them these the list of data points now.
Oh yes, you're right. Why it's done? It's
There it is,
done
line 17.
here.
Do we have
Okay.
all? Yes, we have them all. Data points.
Data points. You did it before. Okay, good. Maybe we can.
Now, people on the chat are
Right.
saying it's much better.
Good. Yeah, so now I'm just printing some debug to check that it's correct. So for each enemy, I will print the ID. Okay, so that's
E.
ID and the ID of the closest
Data point.
closest data ID.
Good.
Oh, we do not forget.
Oh yes.
Okay.
So enemy ID 0, the closest
Is
data point to
correct.
0 is...
That's good.
Yeah, it looks good.
Yeah. If you look at the arm, yeah,
It's definitely
Um,
pointing towards that data point.
Yeah. except for the first one.
That's true, they're all aiming for 1,
Yeah.
except for Mr. 0 over there, who's aiming for 0.
Okay, so that's correct. So what we wanted to do is computing the next.
The next position.
position.
Can I do this one?
Yeah.
Okay, brilliant. So, when should we do it? Straight away, or in only for the enemy that interests us?
We should do it in the constructor of the enemy.
Yes, good idea. So it is here. We're going to be defining next x, next y. So we have the closest data. So I'll call I'll make a new function called private function called compute next position. I don't really need anything but self. I think self dot compute next position.
Maybe you want to do something similar. You want to return the next coordinates.
Self dot next coordinates. We don't have a. Oh yes, we do actually.
Actually, in Python, you can write
That is true.
next
Next
x.
x, comma, whoops,
Yes.
comma, next y. Very good point. So we can return both of those values, which we now have to compute. So we want the vector which goes from this enemy to its closest data point. So let's do that now. So it's closest data x minus self dot x and closest data y minus self dot y. But that vector is possibly much larger than 500 units, which is the speed of these people. So I'm going to have to make sure that... Wait.
Why? There are two cases.
There are two cases.
If,
Either it is...
if you're close enough to
So,
a data point, then your next target will be the coordinates of the data point.
exactly. I don't have the distance to the data point. We didn't save it.
You need to compute it. You can. You have the closest data.
Okay, distance to self.
You should store that into a variable because you will need it several times.
Dist.
Good.
Tell you what, I'm gonna store that in dist. So if dist is shorter or equal to, enemy speed, then next x and next y will be the coordinates of the closest data.
Yes.
No, I need
That's
I
correct.
need to return a tuple, don't I?
You don't need.
Really?
Yeah.
Oh, fantastic. Self.closest data.y. And if it's not the case,
Oh, that's more difficult.
this is the complicated bit.
So you need to take into consideration.
The distance to the target and the distance which I can actually move, which is 500, which is enemy speed. If I divide the enemy speed by the distance to the target and multiply that by the coordinates of the vector,
Okay, if I follow
will
you
that work?
correctly, we have the vector between
Yes.
the current position of the enemy
Yes.
and the closest data.
Yes.
And unfortunately, for the enemy, it cannot go directly to the data point.
Because it's too far away.
Yeah, because it's too but it will keep the same vector. So we just need a projection of that vector. So what we will do is exactly what you
Trying
you
to say.
said. Yeah. Maybe you should write down a variable that represents the global distance divided by.
The possible distance.
What is
Yes, it's the possible distance
No,
divided.
that's the opposite. So you need the speed of the enemy
Yep.
divided by the distance.
The distance, which I will call distance coefficient.
Okay, so if we represent the vector, we should add something to draw. If we represent the vector, we have a whiteboard.
We have a whiteboard.
That's quite difficult to move the camera. If maybe we should have paper and.
Oh, it's good enough. So
Okay,
we have the
so
distance.
if we have the vector, now we have a part of that vector.
Yes.
So let's just multiply distance coefficient
Yes.
to each coordinate of the vector.
Yes. And we will call this speed vector, I suppose, or enemy vector, or actual vector. I'm not really sure what to call it. Okay, so this vector represents the movement that the enemy will make.
Yeah.
And now, thanks to this vector, we will be able to compute easily where he will land.
Exactly.
And to do that, we take the current x and add the x of this speed vector. Am I right? Add it to self dot. Well, no. Self dot next x. No, I'm going to return it. There.
And you need to return the same for y.
For y. And I'm going to put this in a lovely little tuple.
But no need, but yes. That's almost good.
Really? We don't need it? Okay.
How you doing? We need to check the statement because we had integers values and
Yes.
then here,
That's true, it's not an integer anymore.
so maybe we need to round or floor it. What is
That
it?
would be expert rules. The coordinate system of the game uses whole numbers only. If or
Rounded
for an
down.
enemy should land on non-whole coordinates, those coordinates are rounded down. So
Okay.
we need to take that into account. Very good point.
Okay, so we need to
Cast into an integer. And that is what our next y and next x will be.
good. We should try to print it.
Yes,
To
let's,
make sure
let's
it's
do that.
correct.
So where did you print all your data? Here. Print enemy ID. I'm just going to move that away and put something else instead. Or maybe I'm not. I'm going to leave it. And here I'm going to write. You can go if you need to go.
Yeah, I will go.
Next course.
But I want to see if it's working.
Yeah, I understand.
I don't care if I'm late.
Next x and next y. There. Oh. File equals system.stder.
You're missing a D.
You're missing a D. Okay, hang on. Let me just check on a smaller test case. Okay, so for example, enemy number 0, he's aiming for 0, and he's at coordinate 3108000, and we've computed these coordinates here, 2646.
Maybe you should
7700.
copy paste it and print it somewhere.
Copy paste this.
Yeah.
Okay, so that is what we've computed.
Okay.
And the actual next coordinates are 2646,
Good.
7789.
Now I can go. Okay, thank you very much.
Bye bye. Well, let me at least use these coordinates. I'll stop in a moment.
Okay, I will watch later.
Okay, good. Bye-bye.
Bye-bye.
Maxime says goodbye. Well, I hope this is helpful and that it'll allow you to get a good start on this hackathon, or maybe if you've started, it's cleared something that seemed bizarre whilst you were coding. In any case, now that we have these next coordinates, that's what we're going to use in our decision-making process. Instead of checking the distance to an enemy, we were going to check the distance to where the enemy will be, and hopefully we'll get a better score. Yes, that's right. So we won't need enemy speed in the test to verify if we're safe or not. So this dist is going to change. I'm going to comment it out. And dist, I'm going to determine if me, or I'm not going to determine if, I'm going to determine what the distance of me to not the closest enemy, but actually a fictional entity who doesn't need an ID, made from the next coordinates of the closest enemy. There are other ways of doing this, of course, but just to show you off a way of doing it before the end of this stream. So, closest enemy next X and closest enemy next Y. Closest enemy next Y. Making sure. Okay, so now I can remove enemy speed from my calculation because I know that he's not going to move anywhere. Well, that he's already moved, I mean. See, it works. Okay, now where was that test case where I died? Perfect, I didn't die because Wolf is not escaping into the arms of the enemies. He's not going to go towards someone that he knows he won't be able to evade next turn. I'll watch him in action, in slow-mo, or in normal mo. Pow. Fantastic. So with this new algorithm, I haven't checked all test cases yet, but I am going to submit my code to see if it's improved or whether they've introduced a regression. Well, it seems I have. I've got a better score because he uses his gun more efficiently, but I seem to have introduced a few problems with the code, so I'm going to have to debug that now. This is where the fun really starts, but I'm not sure if tonight I'm going to have enough time to show you all in continuing, well, I think what I would do next. There are, of course, many things that someone can do. For example, you could check the amount of life each enemy has and only shoot the ones who don't have a lot of life left first, so that you guarantee that they die before the end of the test. That's just an idea. There are plenty of things you can do. I'm probably going to stop now. I hope this stream helped. I'm curious as to why I died though, so let's see. Wolf moves towards an enemy, the closest enemy, and he doesn't take into account a different enemy. So that would be my next step. My next step would be, when calculating which is the closest enemy and where he is, make sure I am not entering I'm not taking a step which will cause a different enemy to enter my kill zone. Because what I've done here is only take into account the closest enemy. So when it comes to killing the closest enemy, this is the best possible way to do it. But unfortunately there are other enemies involved. So if I want a really good score, a really good ranking, I'm going to have to take into account all of these different variables, the different enemies, where they're going, where I am, how many life points each enemy has, all at once, using the same principles that you've seen me and Maxine use today. Well, thanks for watching, and keep coding.